Hi guys. Okay, so we are on the last section of chapter 2, which is awesome. And so this chapter we started off with the formal definition of the limit. The derivative that had the limit. And then we dropped that and we did a bunch of rules. We did the power rule, the product rule, the quotient rule, higher order derivatives, and application of that with position and velocity and acceleration. And so this last one here is we're just gonna do some derivatives of trig functions, and obviously these are just memorize. There's no easy way around it. All of these are fair game, you guys. They all come up on the AP exam, and when you start to do it, obviously use your notes, and just the more problems you do, you just end up memorizing them just out of sake of making your life easier. Okay, so we're going to jump in here and just kind of go over it, right? Derivative of sine, cosine, negative sign, and so forth. So I'll reference this as we go through. And all that changes is that we have our rules, but now we have trig functions inside of it. Okay, so we're going to find y prime here. Y prime is the derivative of x, which is just 1, plus, right? There's a 4, so it stays there, and the derivative of sine is cosine. And that's it. Okay, so it's not like it's hard. You just have to memorize that the derivative of sine is cosine. Okay, now over here, when you find y prime, everything stays the same, right? You have a function times a function. Now we have a polynomial times a trigonometric function. And so we have to use the product rule. And so we'd say it's the first, which is x squared, times the derivative of sine, which is cosine, plus the second, which is sine of x, times the derivative of the first, which is 2x. And then you just clean that up for your final answer. That'd be x squared cosine of x plus 2x sine of x. And we would put this 2x in front of the sine x just so we don't get confused and think that maybe that's part of the argument there. That's not what happens, right? So that's in front. Okay. All right, then looking at C, we've got a quotient rule here with trig. And so we'd say that y prime is low, which is x, d high, so cosine of x, low d high minus high, which is sine of x, d low, which is just 1, the derivative of x, all over x squared. Again, just clean it up, write your final answer, x cosine of x minus sine of x all over x squared. There's nothing that simplifies there from pre-calc that you would remember or anything like that, so that's an acceptable answer. Okay, all right, over here we've got an exponential times trig, so y prime would be first, e to the x times the derivative of sine, which is cosine, first times the derivative of the second, plus the second, sine of x, times the derivative of the first, which is e to the x. And in this case, I think when you rewrite it, you would notice that e to the x is in both, so we could factor that out, and we could write this as sine x plus cosine x. Okay. All right, nothing tricky so far, hopefully. Down here, we've got the quotient rule, so let's jump in here. We've got low, which is 1 minus sine x. D high, well, the derivative of cosine is negative sine. Okay, so up here in your chart, the derivative of cosine is negative sine. And so when we take that derivative, this is low d high, we have negative sine, minus high, which is cosine. So low d high minus high d low, the derivative of the low. Well, 1 goes to 0. The derivative of sine is cosine, and it has a minus sign, so that doesn't go away. It's like a negative 1 in front. Low d high minus high d low all over low squared. Okay, and then let's simplify and see what happens here. So we've got negative sine x, and then we've got plus sine squared x. Then we've got plus cosine squared x, right? Negative times negative is positive, cosine squared, all over 1 minus sine of x squared. Okay, now there's a pre-calc topic here. Hopefully you guys remember some of they're called trig identities. Sine squared plus cosine squared is equal to a value of 1, right? And so this problem becomes, that's all 1 minus sine x, right, from the front over 1 minus sine x quantity squared, giving me a final answer of 1 over 1 minus sine x. Okay, so you do have to know that sine squared plus cosine squared is equal to 1. That does come up in calc. Okay. All right, so over here we're going to say y prime. is equal to low cosine of t times the derivative of the top. So low d high, or just e to the t, minus high, derivative of cosine is negative sine, all over low squared. Now, I'm going to pause here. This is a very common mistake in pre-calculus. Okay, so let me just make a little note down here. Cosine of t squared is the same as cosine squared t. That squared goes on the trig function, right? It is not the same as cosine of t squared, right? Because this now is your argument, and that's not what you're saying. This means cosine of t times cosine of t. This guy is saying cosine of t times t. Those are very different. Okay, so make sure you understand when you have a trig function that's squared, it goes on the trig function, not on the argument. Okay. All right, so we've got low d high minus high d low over low squared. And let's see what we can simplify if we can. We can take out e to the t, and we're left with, this really is plus, right? Because negative, positive, so that'd be sine plus cosine all over cosine squared. And that does not simplify anymore, so you'd be good to go there. Okay, so just, lots of little examples to work with your trig functions. We obviously didn't do any derivatives of tangent and stuff like that. That will be in the homework, and you can always reference the formulas at the top. Okay, so given this function, find all points where the tangent line is horizontal. That is a definition, you guys. That happens when the derivative is equal to 0. Okay, how come? The tangent line horizontal, if you have a function and you have a horizontal tangent, okay, right there your slope is 0. Well, in calculus, slope is the derivative at any point. So you want to find the derivative set equal to 0. And again, if you're definition based, now you have a starting point. You know you need to find f prime. So let's find f prime first. F prime is 1 plus cosine of x. It told me to set that equal to 0 and solve. So that now wants to know cosine of x is equal to negative 1. Okay, this is an x value that represents an angle. Okay, so you're saying cosine of what angle in radians is equal to negative 1? Okay, well, there's a point on the unit circle right there at an angle measure of pi radians that has a cosine value of negative 1 and a sine value of 0. So it seems, right, that x would be equal to pi. Remember, cosine of angle pi is equal to negative 1. Okay, and so we have our answer. What happens at x is pi? Remember this going backwards thing. When x is pi, f prime is equal to 1 plus cosine of pi, which would be 1 minus 1, which is 0. So the derivative is 0 when x is pi. Okay, and so if that's true, then you know that the tangent line, the slope of the tangent line is 0, which by definition is a horizontal line. Okay, all right. Okay, so we've got a little bit different trig function up here. It wants you to find the second derivative at pi over 4 of secant. Okay, so let's jump in here and find the first derivative. Well, by definition, the derivative of secant is secant tan. Okay, that's memorization. The derivative of secant is secant tan. Now, for the second derivative, you have a product rule, right? You have one trig function times another. And so the second derivative would be the first, secant, times the derivative of the second. The derivative of tangent is secant squared. First, derivative of second, plus the second, tangent, times the derivative of the first. Well, the derivative of secant is secant tan. Okay? So if we simplify that, that becomes secant cubed x. Remember, the cube is on the trig function. Plus, this is tangent squared secant, or secant x tangent squared x. Okay, so now we have that our second derivative is equal to that. They want to know, well, what's the second derivative value of pi over 4? So we need the second derivative at pi over 4, which tells me I need to find the secant of pi over 4 and cube it. Then I need to use that to, again, find the secant of pi over 4, and then find the tangent of pi over 4 and square it, all back to your unit circle, okay? And so let's figure out what secant of pi over 4 is. Well, if we go to our unit circle in quadrant 1, pi over 4 radians is right there. That's the angle. And the point right there is the point root 2 over 2, root 2 over 2. This is the cosine value and the sine value. And so if the cosine is root 2 over 2, the secant would be the reciprocal of cosine, which would be 2 over root 2. So this becomes 2 over the square root of 2 cubed, plus, again, we just said that that was 2 over the square root of 2, times, well, what's the tangent of pi over 4? Tangent of pi over 4, by definition, would be the sine value divided by the cosine value. Well, since they're the same value, tangent of pi over 4 is just 1 squared. Okay, so let's cube this and cube that, and we get 8 over root 2 times root 2 times root 2 is 2 root 2 plus 2 over root 2. Okay. And then let's get our common denominator here. So we have 8 over 2 root 2 plus, let's multiply top and bottom by 2 to get this common denominator. And we end up with 12 over 2 root 2, which would simplify to 6 over root 2. I mentioned you guys in this class, I do not care if you rationalize. This is a great answer. It's exact, right? You've got your square root in there. We're not going to a decimal. If on a multiple choice test you had to pick an answer out, maybe they would write that as 6 root 2 over 2 or 3 root 2, right? We know that that's the same, and you should be able to do that, but this is okay on a test for me. Okay for carp. Okay, I don't need you to waste your time rationalizing things. I need you to focus on memorizing the trig and the unit circle. Okay. All right, so at the end of last lesson, we had a question that was on there. I'm going to change it for next year, but that function required some more derivative skills that we haven't learned yet to get the acceleration function. Similarly, I changed this, the notes that you have, if you print it out, I took out this 2 just to simplify it. Okay, so we're going to start with this position function, s of t is equal to negative 8 sine of t plus 8t. Okay, again, I took out that 2 because we haven't really learned what's called the chain rule yet, and it's not like it's hard, we're not there yet. So let's not make it difficult on ourselves. And so given the position is that, find the velocity, right, of the particle when the acceleration is equal to 0. So you are trying to find the velocity, so underline, that's a definition, right? When the particle, when the acceleration, we know that's a definition, is equal to 0, we'll use that fact. But just from reading this problem, and you have a position function, clearly you need to know the velocity function and the acceleration function. So let's start there. We would say that the velocity is simply the derivative of the position. And so the derivative of sine is cosine, so this becomes negative 8 cosine of t. And the derivative of 8t is simply 8. Okay. Acceleration is the next derivative down, so we would take the derivative of the velocity to get the acceleration. Now, the derivative of cosine of t is negative sine t, so that becomes positive 8 sine of t. And the derivative of 8 is 0, so that goes away. So at least now I have my 3 functions, my position, my velocity, my acceleration. Now all you have to do is go back and figure out what you're trying to find. Find the velocity. Okay, it's right there. But what in particular about it? When acceleration is equals 0. So you need to find when a is 0. So here's your a function, set that equal to 0. If you divide both sides by 8, you get, all right, well, that will happen when sine of t is equal to 0. And then you have to know your unit circle. When is the sine of what angle is equal to 0? Well, at angle 0, that is the point 1 comma 0. This is the cosine, and that's the sine. And so the sine of angle 0 is 0. So we know t can be 0. Well, back over here at an angle of pi, that's the point negative 1, 0, cosine sine. Again, the sine of angle pi is equal to 0. And so pi would also be a time value at which this is true. Okay, so I know when t equals 0 or pi, it causes this to be 0, which makes the acceleration 0. So they say, well, what's the velocity when that happens? Okay, well, when t equals 0, the velocity at time 0 would be -8 cosine of 0 plus 8, which is -8 times 1 plus 8, which is simply equal to 0. So when the time starts at time 0, the velocity is 0. So the particle is stopped. But at time pi, which is weird, but a little bit after 3 seconds, okay, what's happening for the velocity? Well, at time is equal to pi, the velocity at time pi would be -8 cosine of pi plus 8, which is -8 times the cosine of pi, remember, is -1 plus 8, and so we'd get a value of 16. So a little after 3 seconds, this particle is definitely moving which way? Stopped, right, or left? Well, velocity positive is the definition of right. Okay, so we know that at those two time values, we can find the velocity. Okay, so that's a good review of what we just learned last lesson. And that's it, you guys. So we went through, we did all of our rules, right? Power rule, product rule, quotient rule. We learned about higher order derivatives, position, velocity, acceleration, how they're related to one another, right and left movement, accelerate right and accelerate left movement. And we went through today and we learned about derivatives of particular trig functions. Okay, we use the derivative of secant, we use the derivative of tangent. These are more rare. Okay, you don't see them as often on the AP exam, but you definitely need to know them. And when I say that, right, this is all open notes at this point, so you should just be referencing these so that you can work through the problems. Okay. All right, guys, congrats. That's 2 chapters. We only got 3 this quarter, so we're on our way.